Well, hi there, and welcome back to this module on optimization, finding the best possible situation, max or min. Yesterday, in the previous lesson, we worked on area of different shapes, rectangles, triangles, and how to optimize that. Today, we're going to talk about perimeter. Okay, we'll do the same processes of identifying the max or the min. It's just we're going to be setting up our equations having to do with perimeter instead of area today. So this shape should look familiar to you. We worked with it when we were working on area. Now we just want to work on it with perimeter. So I'm going to inscribe a rectangle again. And just for review, I'm going to label what the corners are. So we're going to call this corner x comma 0 because again it is to the right of the origin, and then negative x comma 0, x comma y, and negative x comma y. Okay, our question here is the largest perimeter. So our goal is the max perimeter. Our variables again are going to be base and height. So the base is 2x and the height is y, but y is equal to 8 minus x squared. Now this time the equation we're going to come up with is a perimeter equation, and so the perimeter is 2 base plus 2 height. That's the perimeter for a rectangle. So this would be 2 times 2x and 2 times 8 minus x squared. So overall our perimeter comes out to be 4x plus 16 minus 2x squared. So that's our perimeter. Now this might be something that you should be able to do without a calculator now that we move to the derivative as we optimize, so p prime. And the derivative of this would be 4 minus 4x. Now, I don't need a calculator to set this equal to 0. So this might be something you would do without your calculator. I can set that equal to 0, x is 1. I could also graph it, and the line would come like this, and we would find x is 1 again. And that's the max crossing from positive to negative. So our critical point is x equals 1, which is going to give me a max. So now the answer are what are the dimensions, and so I want to go back and figure out what the base should be and what the height should be if this is going to have the largest perimeter. So the base would be 2 times 1, and the height would be 8 minus 1 squared, so that would be 7. So this rectangle should be a 2 by 7 rectangle. Okay, 2 by 7. That's a really skinny rectangle. And so the drawing of that is actually a rectangle that looks more like this. It's a really tall and skinny rectangle. But I didn't know that when I started out the problem. I started with that's an arbitrary rectangle, and it turned out that the largest perimeter is the skinniest rectangle. Okay, here's another one with perimeter. What is the smallest perimeter for a rectangle? Okay, now we're on smallest, whose area is already 24 inches. All right, the smallest perimeter. So that's my goal, is minimum perimeter. My variables are not necessarily on a coordinate axis this time. So I'm going to need to draw my own rectangle. Then I'll call it x, and I'll call it y. And I know that the area on the inside is equal to 24. How do we get area? We get area from x times y equals 24. All right, so my base is equal to x. My height is equal to y. Now, do I have an equation for y? I don't have an equation for y like I did in this problem, where I specifically had y equals 8 minus x squared, but I do have something for y in the equation x times y equals 24, because if I get y alone, it would be 24 divided by x. So I do have something I can use for y, and that y is 24 divided by x. Okay, my perimeter will be 2 times the base, so 2 times x, plus 2 times the height, so 2 times 24 over x. And for this one, we can do a Math 8. Okay, we won't do it on our calculator. We'll find the derivative with Math 8 and graph it. As I graph this, I'm going to do a standard window from -10 to 10. And the graph that I get looks like this. And I need to look for, this time, the minimum. So I want the place where it crosses the x-axis, so it's crossing from negative to positive. So that's right here. So I want to identify that as the critical point. And so I'll do a second trace, and I'll come up with the minimum to be 4.8989, which, when we round to 3 decimal places, will be 4.899. Now this should give me the minimum perimeter. And remember, if you have done this on your calculator, this is the second trace, and you did the 0 and you got this value, you can now type in 2x plus 48 divided by x on your calculator and actually get the perimeter value. If you did not do it, you'll have to, if you've erased it or done something, you'll have to type in the 4.899 on your own. But if it's the last thing you did on your calculator, you can go ahead and evaluate it this way. And you should get 19.5959, or 596. That is the smallest perimeter with the given area. And we need units this time. We were given the area to be square inches, so perimeter is just in regular inches. This is also inches. All right, find the dimensions of a rectangle with perimeter 22 and area 18. So now we know both the perimeter and the area, but we don't have a picture, so I'll make my own. And I just usually call my base x and my height y. And I know the perimeter is 22, so that means 2x plus 2y equals 22. And I know the area is 18, so x times y equals 18. So I can solve for getting y alone in one of these equations and substituting it back into the other equation. So I'm going to get y alone, I think, in this equation. Subtract 2x from both sides, so 2y equals 22 minus 2x. And then I'm going to divide everything by 2. So y by itself is 11 minus x. I can substitute that into my area equation for y. So then x would be multiplied by 11 minus x, and that would be equal to 18. And I would distribute. And so I'll have 11x minus x squared equals 18. Now a squared problem, you have to set equal to 0. And so I move pieces of the equation around so that I can factor it. Once you have it set equal to 0, you can factor. And this factors into x minus 9 and x minus 2. So x is equal to 2 and 9. So then I can make sure I've answered my question. My question is, find the dimensions of a rectangle. So I have the base. The base is either 2 or the base could be 9. And then to find the y, I want to plug 2 and 9 both into my expression. So if I plug 2 in, then I get 11. And then if I plug 9 in, I get 2. So all that's basically telling me is either my rectangle is 2 by 9. Whoops, I wrote the wrong thing, sorry. I said 9 and I wrote 11. My rectangle is either 2 by 9 or 9 by 2. That means the rectangle is either landscape or the rectangle is portrait this way. Either way, those rectangles both have a perimeter of 22 and an area of 18. Okay. Now here's two shapes side by side, a rectangle and a square. What dimensions should be used? All right, a rectangle and a square. All right, and the goal is minimum. So my goal is the minimum amount of fencing for making this enclosure. So my goal is a minimum. My variables are base and height again. For my base, for my rectangle, I'll call it x, and that will go from here to here. And my height would be y. My base is x, my height is y. Now for the square, all the sides are y. So it's got all 4 sides. And then the rectangle also has x on the top here. My equation is not just about the perimeter. My equation is about all of the pieces that are formed by fence. So not just the outside, but the inside as well. So I'm going to say F for fence, not just P for perimeter, but F for all the pieces that need to be a fence. So this would have 2 X pieces. But if you count up all the Y pieces, there would be 5 of those. So that is the amount of fence I would need. But how do I express something for Y? Okay, I don't have an exact equation given, but I was given the 1,000. So 1,000 has to do with the area that the rectangle and the square are forming together. So the rectangle area is x times y. Plus the square area is y times y. And together, that's supposed to make 1,000. So I should be able to get one of the variables alone here to help me out. You never want to just leave x and y as your only variables. You should be able to somehow get one of the variables alone. So there's only one x in the problem, so I'm going to work on getting that one alone this time. So remember, y times y is y squared. So x times y is 1,000 minus y squared. And then I can divide by y, everything. So x would be equal to 1,000 divided by y minus a single y. So I'm going to come back and say, well, that's my base. That's what x is equal to, 1,000 minus y, over y minus y. So in my equation, I'm going to replace x with that expression. So f is 2 times 1,000 over y minus y plus 5y. That is the equation for my fencing. And now I would like to find the derivative of that, f prime. And you can use Math 8 again to find this derivative. Now, when you do use your calculator, the equation on paper that we worked with is y. The calculator can only do x. You'll still get a valid answer if you type in x in place of y on your Math 8 graph, and that's really, it's going to be okay. It's just that the calculator can only graph x variables. If you don't like that, if that bothers you, then you can go back and start this question over and switch all your y's to be x's and all your x's to be y's and like redo the problem if it bothers you, but hopefully it doesn't bother you too much. All right, as I get ready to graph this, the window I'm going to use is 0 to 100 and negative 10 to 10. And so what I'd like you to do is set your window the same and then pause this recording right now. And I want you to graph your own Math 8, and I want you to find your own critical point. And then resume the recording and to double check that you've done it right. Okay, don't just watch me do it, but do it on your own first. Okay, so pause the recording now. Okay, hopefully you just graphed that, and hopefully you saw something like this, where this is the value we're looking for that is a minimum, okay, where it's crossing our x-axis, that most important point from negative values to positive values. And that critical point is was 25.8198. Now, let's talk about rounding here. If the 8 needs to round the 9 up, then what happens? You got to look at like this whole thing here. Okay, the 8 needs to round the 9 needs to round the 1, so it's basically thinking of 19 needs to round to 20. And so my rounding would be 8.20. But you should have that stored in your calculator anyway, so that you can use that to find the dimensions. Okay, so this is a min. Oh, and I messed up. This is not the value for x. Remember, the calculator was doing x, but this is actually the value for y. So the height is 25.820. The base, you need to plug that value back into the 1,000 over y minus y. And so that will give me 12.9099. So here's another chance where that 9 has to round the 9 and the 9 has to round the 0. So then we're looking at 10. So that's the value of the height, and it's the value of the base. Does that answer the question? Not quite, because the question is still, what are the dimensions all the way across the whole shape altogether? Okay, so the dimensions all the way, I better clear that out. I'm going to put it back to what I used it for. This I called x and this I called y. All right, so the height of this, for sure, 25.820, but the base, the dimensions need to include the x and the y all the way across together. So you'll have to add those two numbers to give me the full length of the dimensions across the bottom. All right, last one. Here's another fence, this time up against a wall. Okay, it's 3 rectangles all next to each other. what is the largest area that can be enclosed? All right, so our goal is largest, so it's max. Our variables. I'm going to call this section X, X, and X. So my base, okay, it's all those X's across the bottom. My height will be, I'll have Y's, and that'll be a fence. These will all be Y pieces. But I would like to come up with one of those to be something not X or not Y. So what else can I do? It has to do with this 200 feet of fencing. Okay, all of those pieces of fence need to add up to be 200. So there are 3 X pieces and there are 4 Y pieces, and that needs to be adding up to 200. So we need to get one of these variables alone. This time I'm going to get Y by itself. So 4y is 200 minus 3x, and divide everything by 4. So that gives me y equals 50 minus 3x over 4. Excuse me, I need to answer the phone. Okay, 50 minus 3x over 4. So the equation that I need is an equation for area. And area is base times height. But take a look at your picture. How long is the actual base all the way, all the rectangles combined? So the actual base has to represent the full length. And so the base would be 3x. And the height is just a single y, so that's 50 minus 3x over 4. And for our derivative, again, you can use a math 8. This time when I graph my math 8, I'm going to do 0 to 50, from negative 10 to 10. And again, I'd like you to pause the recording, graph that on your window on your own, and then find the critical point ahead of me, and then use me to check it. All right, hopefully you've graphed that, and the graph comes down this way, crossing the x-axis. It crosses from a positive to a negative, so that would be the max. And the critical point was 33.333. Now, have we answered the question? What is the largest area? So we haven't actually answered the question yet. We need to take 33.333 and plug it back into the area equation, which was 3x times 50 minus 3x over 4. And again, you can use the home screen of your graphing calculator to do that if you have recently found the solution. So that turns out to be perfectly 2,500 is the maximum area. Now let's look at our units. The units that we're measuring this fence in is feet, and so the area would be measured in feet squared. So I hope that's enough for you to be a little bit more comfortable with the idea of perimeter and area working together. There's always enough information in your for your variables to be expressed where one stays the same and the other one should be converted into a different value. There's always enough information in the equation for you to do that. Okay? Don't forget, just going to push the Friday signups to come on in to get some help with this geometry / calculus stuff. All right? Other than that, I hope you have a great weekend.